everyone. Namaskara. So in the previous classes we have discussed about support reactions, loads, types of loads, forces which are coming on the structure, beams, columns, purpose of the structures. All these things we have discussed. So in this class we will discuss about the centroid. What is centroid? What is the significance of centroid? So what is center of gravity? What is the difference between them? So what are the main formulas? Some of the formulas of main surface bodies. We'll discuss about that. So let's start this. See, just look at this. This is the Halmidi Shasana, the inscription, the first Kannada inscription, which is there in Hassan district. Now, as far as center of gravity is concerned, just look at this inscription. Just assume if I want to lift this. If I want to lift this, I need to tie a rope for this. After that, I will be lifting. So when I am tying the rope for this, I need to tie at the place where I need to apply less effort to lift this. So what I will do? It's a common sense. I will tie a rope for this. Then I will tie one more, or I will make a knot and I will lift this. And this is the place. Where is the place? Which is that place? That place, that position is almost at the center of this object. Then look at this, the stone chariot of Hampi. If I want to lift this, or if I want to pull this, lifting is not possible, just forget about that. If I want to pull this, so I need to make the arrangements in such a way that the maximum force should be applied at the center. In fact, even 100% of the force is applied at the center, it will be very easy to pull this. And also, just look at this. These are the wheels of this stone chariot, and this, whatever you can see this, which has been, the wheels have been attached exactly at the center. Even if you see the thickness in this direction also, that will be applied exactly at the center, that have been fixed. So why we are doing this? From this, if you are going for the theory in engineering mechanics, that we call it as center of gravity. So this is the object, the solid object, where most of the weight or most of the mass of the body is assumed to be concentrated. That means if you apply the load at that point, it will be very easy or easiest to move the object. That is the center of gravity. Now just look at this. If I want to write this in our notebook, how I will write? I will write just like a circle. Then center of that will be represented this, like this. Even if this is, it is in a rectangular shape, the center will be represented like this. In this, it is not the mass, it is the surface area. So in the plane figures, where the whole area is assumed to be concentrated, that point is known as the centroid. See, in both cases it is center only, center here, but in the plane figures we call it as centroid. In the solid figures we call it as center of gravity. Here it is the mass, here it is the surface area. So finally, the centroid and center of gravity is like that. The point at which the whole surface area of the plane appears to be concentrated is known as the centroid. And point at which the combined mass of the body appears to be concentrated is the center of gravity. As we have seen, even if you take the simple pendulum, whatever you are tying this rope at the center of this object. So this will be center of this object. When this is the solid, the whole mass is assumed to be concentrated at this point, so it will be fixed for this point. So that is the assumption, or that is the theory behind centroid and center of gravity. So in our chapters, Normally, in theory, we can use only the plane figures. We'll be dealing with the centroid. So, remember once again, the point or of any plane figure at which the whole surface area is assumed to be concentrated is known as the centroid. Now, come to this. I am writing simple rectangle or square, whatever it is. Here I have x axis, here I have y axis. Is so the center of that is assumed to be concentrated. This is the center, and this distance from y axis in the x direction is x bar. X bar is the distance of centroid of a given plane figure from y axis. So distance in the x direction, just remember that distance in the x direction, and of the same case distance in the y direction from x axis to the centroid is y bar. So x bar and y bar are the coordinates of the centroid. So normally we'll represent centroid by using C or G. So this is the centroid. This is the theory behind that. Now just look at this. If I am having the objects like rectangle, simply I can write this is the center. If I am having circle or the square, this is the center. If I am having the circle, this is the center. But if I am having the compound plane figures, just like this, see, rectangle and triangle, combination of rectangle and triangle, even half of the circle has been included. We have various shapes like that for the machines, for the structures, for civil engineering structures, various machines like this. So for this, we should find out the formula. We should find out some theory or some practice that is known as the principle of moments. For that, to know that, I should know what is the centroid of semicircle, square or rectangle, triangle. So for this, we have the normal standard formula which have been derived by the first principle. But I am not going to derive that. If you want me to derive that, please comment in the comment box. I will try to derive that equations. Now, as of now, just look at that. Suppose if I am having some of the important plane figures or the standard plane figures formulas, if I am having the rectangle, so normally what we will do, so this is the rectangle. If I am having this as x axis, this as y axis, the centroid of this will be like this. So this is B and this is D, depth of the rectangle. This x bar will be B by 2 and this y bar will be D by 2, just exactly at the center. Next we have the triangle. Give your full attention for this. If I am having the triangle like this and this is my x axis and this is y axis, this distance, this is the height and this is B and this is the centroid. If I am having this as the centroid, this y bar will be equal to h by 3 from base. This is what x axis, this is what y axis. Please remember that if the triangle should be like this, then from the base it is h by 3, from the apex it is remaining h minus h by 3. So that is 2/3 of h. So this is in this case when I am having this and I am having this. Of course, in this quadrant we will be writing minus. You will be knowing that from your basic mathematics. This is the rectangle h by 3 and this in this case if it is B, it is by looking at that only you can remember, you can find out B by 2. So next, so that's about the triangle. If I am having the rectangle or right angle triangle, if I take this, this is B, this is H. Normally you will be having this as the centroid and this will be your x axis and this is y axis, and this formula from the base, again from the base it is h by 3, whatever the distance is there, that divided by 3 from base, and this will be b by 3. The remaining thing will be b minus b by 3, h minus h by 3. That you should remember. So from the base it is h by 3, from the apex it is h minus h by 3. The remaining thing. If I am having right angle triangle in this direction, so this is my b, this is by h, this distance is h by 3, this distance b by 3, but since it is towards the left of the x-axis, we can write it as minus b by 3. That's it. That's about the rectangle. Then we'll go for circle. If I'm having the circle which is attached to the x-axis and y-axis, of course d by 2 or r. This direction is r, d by 2 or r in both direction, x-axis and y-axis. Now we need to go for the semicircle. So you will be having semicircle in different directions. Just look at this. I am having x-axis and y-axis. Then let me take this as x-axis, this as y-axis. Now let me have this. We can have like this also, semicircle. We can have the semicircle like this. We can have the semicircle like this. We can also have the semicircle like this. Please remember this. This is x direction. This will be the center. This direction. By looking at this only, we don't want any formula for this. So this we can take it as r. And the distance from the base, from the diameter towards the end of the circle, we have the formula 4r by 3 pi. Even if you take this comes in this direction, this distance 4r by 3 pi. The remaining things is r only. Just please remember this. You should not get any confusions in this. This from the base, starting from the base or from the diameter towards the end of the circle, the formula is 4r by 3 pi. Wherever you can see, there you can write as it is r. From the common sense you can write r, that is d by 2 is r. So this is what the semicircle. Next, if I am having quarter of a circle, just look at this. If I am taking this as x-axis, this as y-axis, the quarter of a circle, even if you take this, see, from the base towards the end of the circle, this is also 4r by 3 pi, this is also 4r by 3 pi. So this is what we have. So in summary, we can understand that for the rectangle, we have A is equal to P into D area, x bar is equal to B by 2, just what is the distance, by 2, then y bar D by 2, the total distance is D here, half of that is D by 2 for the rectangle. Then for the triangle, area, area is equal to half into base into area, height, x bar is equal to B by 2. By looking at this, just remember that wherever it is possible to find out the center as it is, we should find as like that only. We should not blindly apply the formulas. I have seen some of the students, even for x bar also, they'll write B by 3 or something like that. No, it's not like that. Wherever we have the base, from the base, the distance is the total distance of that side divided by 3. So y bar is equal to h by 3 in this case. Then if you have the right angle triangle, x bar is total distance, this distance divided by 3, and y bar is h by 3 from the base. The remaining thing is h minus h by 3, b minus b by 3. That you should remember. Next, we have the circle. We have the circle here. Area is equal to pi r square, r pi d square by 4, and x bar in this direction is d by 2 or r, y bar is d by 2 or r. Next semicircle, we have pi r square by 2 is the area. See, this is the semicircle we have here in this distance. So that means if you are moving from the diameter towards the end of the circle, in that distance, the formula we have is 4r by 3 pi. So this has been derived from the first principle. Y bar, by looking at this only, you can find out it is d by 2, that is equal to r. Next we have quarter of a circle, area of that will be area of the circle divided by 4, 1/4 of area of circle, pi r square by 4. Then we have x bar is equal to 4r by 3 pi, y bar is equal to 4r by 3 pi. Just look at this, x bar is moving in this direction from the diameter towards the end of the circle. In y direction also, from the diameter towards the end of the circle. In that direction, the centroid will be equal to 4r by 3 pi. So these are all the formulas we have for some definite or the figures, the standard figures for which we have the formulas. Now look at this. Suppose if I am having rectangle, triangle and semicircle. See, I am having three plane figures. See, we have 1, 2 and 3. So what I need to do, for each and everything I will be having from one distance. I can take here, I can take somewhere else, whatever it is. This is the reference axis we are taking. X bar is equal to y bar, x bar and y bar. So now the formula for this will be equal to a1 x1 plus a2 x2 and a3 x3 divided by a1 plus a2 plus a3. So this you can write it as sigma of ax divided by a. So capital A. This you can take it as capital A. So this a1 x1, see, area of first plane figure, a2 area of second, a3 area of third plane figure. x1 is a distance from y-axis to the centroid of first plane figure. See, in this case, so this distance is 4r by 3 pi and the remaining distance is r minus 4r by 3 pi. Please remember that this will be doing once again when we are solving the examples. Here x2 is the distance of second plane figure from y-axis. Y-axis is same for all these different plane figures because this is a compound plane figure. Next, x3 is the distance from y-axis to the third plane figure. So this is your x3. So like that we need to find out, and then we will be getting the centroidal coordinate in x-axis. Similarly for y-axis, you will be having sigma of ay divided by capital A, area of whole plane figures. So that will be equal to a1 plus a2 plus a3. So this is what we have, and this we can find out, and we will solve some more problems in the next class, and we can understand this centroid concept in a better way. Thank you.